Good morning, everyone. So last time we just started to learn about each other, who we are, and I started what I can now call lecture zero. We discussed what do you think about intelligence, and I gave you some questions to look at the comprehension of the topics we discussed. So one thing that I noticed, and as a feedback to this is the diagnostics from the test, is that the difference between intelligence and learning. That is one question that many of you have not answered correctly, but I'll quickly discuss um, whether learning is intelligence or not. So last time we discussed that an intelligent system has the ability to learn, but learning itself is not intelligence as far as behavior scientists are concerned. In robotics and in artificial intelligence machines, many times we confuse that a machine which is able to perform tasks better or solve problems better, they are perhaps more intelligent. But as a traditional and the cognitive science concept of intelligence goes, learning itself does not increase your intelligence. Although there is a debate whether intelligence can be of an individual can be improved or not, but broadly speaking, in a conservative way, intelligence is not increased by way of learning. But the ability to solve problems does increase after learning. So an intelligent machine is one which has the capability to learn. But the intelligence, so an intelligent test, for example, should not test you on your ability to solve problem, but try to eliminate your own exposure to certain problems and try to get your mental age versus your chronological age, and the ratio is that is what is known as intelligent quotient. So with this little clarification that learning in the theoretical sense of the cognitive science is not intelligence as such. We'll come back to whether intelligence is more desirable or learning is more desirable. That will come to this question later on. So today I proceed from there further, and we talk about what we discussed last. Was this? So there are three pillars of intelligence: learning, noticing, and fixing. So first, we learn from experience, the ability to acquire knowledge, retain knowledge, and use of knowledge. The three aspects of experience is learning. We also recognize problems. To, as I said last time, we look at our environment, and from the environment or the any system that we observe, we notice that there is something wrong, there is some problem associated with it, or we look for some opportunities, and then recognition of these opportunities is also an intelligence. And solving problems, of course, we have been discussing this point of solving problems frequently. So intelligence quotient, the term was given in 20th century. It's not very long ago that people have known IQ for thousands of years. It's not like this. IQ was introduced by William Stern in 20th century, and then the actual test for IQ was originally developed in France by a psychologist called Alfred Binet. He developed the first IQ test, and the goal of that IQ test was to identify school children who needed extra academic assistance. Of course, if a student is prodigy, has a very high IQ, he need not perhaps study with the other students who are relatively not at par with him in the pace at which he can learn. So the ability at the rate at which a student can learn should also determine his curriculum. That with this idea, people would have liked to know their IQs. So intelligence testing has emerged as a widely used tool that has led to developing many other tests. So you may have appeared at some competitive examinations where they also include IQ test, and it remains debatable. It continues to spur debate whether such a testing, what component of such a test is actually cultural. So as I said in the beginning of today's lecture, that learning should not be part of the intelligence measurement. So every exposure or cultural background that we have, the school that to which we go, and the family in which we live, the friends we have, all of them influence. They are actually part of our learning process. they alter our ability to solve problems, to do all those three tasks which measure IQ. And therefore, there has been a controversy and there has been a debate. What is a true IQ test? I here stop screen, and I would like to take a little test with you. This is an experience of one of the greatest scientists, Isaac Asimov. How many of you know about Isaac Asimov? Can you raise your hands? Have you heard of him? So Isaac Asimov was basically a biochemist, but he also wrote a lot of science fictions. You may go and check about his work later. But it is in one of his essays about intelligence, he says that he used to typically score 160 in IQ. You know what is an average? What is a normal IQ score? How many of you have ever taken an IQ test? Just raise your hands. You can use your digital raise hand. How many of you have ever taken an IQ test? You're not participating with me. No one has taken an IQ test?
No, sir.
It's not. So not, I
No,
mean,
sir.
on the net, there are so many IQ tests available, and people just for fun also take an IQ test. And many places for the entrance test, they give you IQ test, and there are many competitive examination for jobs also, which contain have a component of IQ test. So IQ tests typically are a set of questions. Do you have, even if you have not taken IQ test, do you know about it? Anybody can tell me what they think an IQ test is about? Have you heard the term IQ to begin with? Just be participative. Don't be mute listeners of this. You can do that. If you just have to listen, you can just go to YouTube and listen. Be participative in this class. Yes or no. You can say no, you have no exposure, or you have never heard of the term IQ. This is fine. So how many of you have heard the term IQ? One? Only one? Two of you? Wake up, friends. Be here. Be part of this class. Yeah, now you are. So I can see many hands rising. So almost everybody must have heard about an IQ test. And can somebody tell me what an IQ test is all about, what it does? I actually asked this question in my last comprehension, 5 questions that I gave you last time, related question. So can just somebody come forward and tell me what they think about an IQ test? What does it measure and how does it measure? Just to begin the discussion, somebody should say something and I can complete that. Come on, guys.
So IQ test is intelligence quotient, where there are set of questions which are asked, which our human gives, and according to the answers, like how much he scored, uh, he was given that according to his age, like there are
Yes.
set of questions according to the age of person, and accordingly is judged that
Yeah,
how
yeah, great.
intelligent he
So
is.
yeah, so as you can you point out, just come forward. I think you all know much more than what you are speaking, and maybe in many things you know more than me. So just show off your knowledge here. And so yes, IQ test is a set of questions. Each question has a particular expectation that a child or an adult of this particular age should be able to answer these questions. So this determines their mental age. So what if I am 20-year-old and if I can answer questions which are expected of a 30-year-old person, what is my IQ? So it is basically a ratio between the mental age and the chronological age. Chronological age is the age on your calendar from your date of birth, and mental age is based on the kind of questions that you have answered, at what age these questions are expected to be answered by anybody on an average. So this IQ tests are supposed to be neutral to your cultural background and neutral to your previous experience. They have to be they have to look at your mental being, what mental age. So psychologists have studied this, at what age what kind of operations are expected. When a child is 2 year old, he can distinguish between certain kind of objects. When a child goes to this age, he is expected to have a certain amount of vocabulary, etc., etc. So there are certain tasks which these psychologists have studied, that these tasks can be performed at this age, and based on that, people are given a score. So this Isaac Asimov story that I was talking about, he used to get a score of 160 in many of his tests. So he was one of the most intelligent persons around him based on these IQ tests. And he narrates a story that he went to a motor mechanic, and he was asked some questions by this motor mechanic. And I will ask some related questions to you. If some of you can come forward and answer this question. So the question is that this motor mechanic asks him, if a mute person or a dumb person who goes to ask for hammer and nail, let us say, forget about hammer and nail, that may be more difficult. And if he asks for water, how will he ask for water because he cannot speak, right? So if when a mute person goes to somebody and he wants to ask for water, how will he ask? Can somebody tell me, how will he ask?
He will use the sign language.
Yeah, he will use the sign language. So what sign will he make?
Like drinking.
So you are
like,
not on camera, so I can't really get the full contribution from you. But yeah.
So, but like as we drink water, the way we
Yeah, so
usually.
he will do like this. So he
Yes.
will make this gesture. Okay,
Yes,
give
sir.
me water. So he will do this. So the next question this motor mechanic asked was that, okay, then next he asks is, if a blind person goes to ask for Caesar, how will he ask for Caesar? What is your answer? Caesar.
He will say it.
Yes, exactly. So you are intelligent. Your IQ is good. So Isaac Asimov was fooled by this, because in the first question, because he's talking about a mute person, he answered from a gesture. When he next question was asking for Caesars, so he said he will ask for Caesars like this. So he made a gesture for Caesars also. That's what many people would do, because first question, then when you are asked, and then in your mind you create what is called a mental set. So in the mental set, you are in the world where you are picturizing the every individual as kind of mute or dumb. And the next question, you do not pay attention whether this person is not mute. This person is only blind, he can speak. So Isaac Asimov, having an IQ of 160, was easily fooled by this. So he writes in this, and this is a slide where I'm also giving you the link of the incident that he has mentioned. I just removed the screen so I could ask you this directly and see whether you are more intelligent than Isaac Asimov. So if you look at this incident is not mentioned here, but you can look at his essay. Um, yeah, right. So this is the link. talentdevelop.com has a copy of this. So in this he says the name of this essay is "What is Intelligence Anyway?" And he talks about that idea of intelligence itself is very controversial. What is intelligence to one person may not be intelligence to another person. And there are many factors. In this example, now psychologists understand this phenomena, why people can get easily fooled, where by giving one example, the person was not able to answer the second question because it creates what is called mental set. Now, we are not just talking about theoretical psychology here. This all has very profound implications to machine intelligence. When you try to develop algorithms or methods or doing machine learning, all these phenomena that we are talking about in psychology are also experienced by machines. And that's why it is interesting to understand how people have studied these concepts in psychology in the past. So now a little bit about theory of intelligence. This will be my last lecture today to be talking about psychological ideas. Then we'll only be talking about them in passing when in the context of computation. So the theory is, even before I present that slide to you, I will again ask you the question and try to build this theory from yourself. So what is your idea that if a person is intelligent in one task, do you expect that person to be intelligent in every task? Or you think that intelligence is task specific? One may be good, or if I take the IQ for certain type of tasks, I will have one IQ, and I take the different types of tasks, I will have a different IQ measurement. What is your idea about whether intelligence is of a general nature or it is of a highly specific nature? Your ideas. Come on, guys. I mean, you all experience world, your friends, your teachers, your youngsters, your elders, and about many of them, you must be having an opinion that this person is very intelligent, this person is not so intelligent. Even though you have not given them an IQ test, but you still form some kind of an assessment that this person, and then based on your assessment of that person's IQ, you talk to them. You do not ask very difficult, very intricate concepts to somebody whom you think will not be able to understand them. So having experienced world around you, whatever experiences you have, on based on that, do you think if a person is intelligent and good in solving one kind of problems, will he be good in solving all kinds of problems?
Specific?
Yeah. Yeah. So Sanya,
Yes.
is it? You think it is specific?
Yes, sir.
Let me have more opinions. So let's have a vote. Some more people can participate. Perhaps they don't want to speak.
Sir, it
Um,
is general.
So let us vote. How many of you think that intelligence has a general nature? And if a person is intelligent, he or she would be intelligent in everything. Just raise your hands in support of general. I have 7 hands rising. So can you now 7 lower your hands and let me hear, because many neutral will be on their side. So how many of you think that intelligence is specific to tasks? Okay, so I have 11 votes here, which say that it is specific. Some have gone back. So why the number is going back? So people are changing their mind. Okay. But I'm glad that at least 20 people participated in voting. The remaining 6 who have not participated, please wake up. Join us here. So there is a greater number of people in this class who think that intelligence is specific. Now, if you have to do research and you have to give an objective answer to this, how will you test this? How will you design your experiment to prove your point? You want to say it is general and you want to say it is specific. Now, how will you do the research and give a scientific explanation? Now, you're saying that you're giving this answer based on your intuition. Now, translate that intuition into scientific knowledge. How will you do it? Can somebody tell me how would you do it? How will you test for yourself? Maybe I'm wrong, maybe I'm right. So how will I ensure that my answer is correct, or how do I reach my correct answer? How will you design a simple experiment to know whether intelligence is specific or general?
Sir, we can test it in group of peoples.
What will I do?
Uh,
How will I
I'll
test?
take I'll take suppose 10 people and I'll give them the same 10 questions, or I'll give them I'll tell them, I'll ask them to tell me the task in which they are confident of, and then I can test the same. I can have two experiments, one in which they are confident and one which is general and which is like I am designing the questions, and according to the results I can figure out whether my observation or which my hypothesis is correct or not.
Yeah, so one way is you say you make different groups and different groups are giving different performance on the tests. You can say that perhaps intelligence is not universal or it's not common. That's what you're saying? And if I
Yes,
can
sir.
refine your answer more a little bit, what I will do is instead of stratifying groups, I will stratify tasks first. I will first identify if I think that there are 4 types or 5 types of tasks, I will create questions based on 5 different types of tasks. And then I will choose a sample of population on which I want to make a test. So I give this test, then I can look at the correlation coefficients between the scores in one type of task. Suppose I have 4 types of tasks: task 1, task 2, task 3, and every individual has certain score on it. So I will have 4 set of numbers, and I can look at the similarities between the distributions, because now I have for every individual their marks in each one of these tasks. So I can look at the Pearson correlation between their marks between task 1, task 2, task 3, etc., all against all correlations, and I can see if there are any similarities or not. Right? This is how I will approach this problem scientifically. And so now, how will you draw the conclusion? Suppose you found no correlation between the performance scores in one task versus another task. What would be your conclusion?
Specifics, intelligence is.
Then your conclusion will be that intelligence has specific, the task group 1 has no relationship with task group 2. So there will be people who are good in task 1, they are not good in task 2.
Sir?
So,
excuse me, sir.
Yeah.
Sir, in problem solving, there are 2 aspects. One is that there should be domain knowledge, and the other is to be able to apply that knowledge. So I think that the domain knowledge is a separate thing, and to apply the knowledge is like the general field of, is the general aspect of intelligence that is involved.
So domain knowledge is not intelligence. I think knowledge may help in solving problems, but it is as such, knowledge itself is not intelligence. Knowledge is different from intelligence.
Yes, so that is why I think intelligence is of general nature.
Oh, you're saying, yeah, so you're saying that if we have the right kind of domain knowledge, yeah, I understand your point. What you're saying is that specific, this ability to score specifically on different tasks comes because of the domain knowledge. One may have a domain knowledge of task 1, that is why he's performing better in task 1. Another may have a domain knowledge of task 2, that is why he's performing better in task 2. That's what your argument is, right?
Yes, sir.
Yeah, so that's perfectly fine. But that is, if the domain knowledge is influencing my ability to perform certain tasks, it is not really a good measure of intelligence. A good measure of intelligence should be independent of my background, my culture, my exposure to culture. It should be as neutral to that as possible. Of course, it is impossible to do it, but that should have minimum contribution from my previous experience. And if it has secondly, here, remember the test I designed had already covered this, because I am taking the same group of individuals and I'm not testing correlation between individuals. I'm testing the correlation between a group's ability to answer questions on task 1 compared to the same group's ability to answer questions on group 2. So it is independent of, so I'm not stratifying subjects, I'm stratifying questions. You understand, Aditya? If I stratify groups of individuals, background, so if
yes, so that is what I was saying also. That
yeah, so here I'm not stratifying groups. I'm not stratifying individual groups. So that would have been flawed. If I did not, then I will have to be very careful about how do I sample my group. But if I have taken a random sample, if my random sample is representative of a particular population I'm studying, and in that, now I have classified my tasks, and it is the entire group, so which I'm testing. I'm testing whether this group individual subjects, when they perform task 1, are they also good in task 2? So I'm looking at the similarities between tasks, not similarities between individuals. So your concern has been already taken care of in this particular design of experiment. But of course, this is a very good valid question that you are saying, that is the ability to perform better in a specific task may not be due to intelligence. It may be simply because of specific exposure or a specific kind of domain knowledge that the individual has. Well taken, perfect. Any other point you would like to say? So great. So now we understand that if we give this test, and if we find that the scores on different tasks are related, then we will say that if I see a high correlation between the different tasks, what would you conclude? That intelligence is general or intelligence is specific?
General, sir.
General. So now, this kind of idea of designing this experiment and looking at the people's intelligence, this came to one of the psychologists, and he performed a lot of experiments on people's ability to answer different types of questions. And he was Spearman. I'm sharing this slide. So based on this analysis, he gave this idea of two-factor theory. And this two-factor theory says that every individual has a common general ability of intelligence. Basically, your answers and general and specific both are valid. So every individual has a general intelligence, and that is what he called the G factor. And then every individual also has certain specific intelligence, which he called specific intelligence. So G plus S is the total two-factor. One factor is G, one factor is S. And these S factors may be verbal. Some people are very good in verbal skills. They can communicate very well. They can write very well. They can read text very fast and comprehend it. But they may not have any ability in mechanical tasks. And some may be very good in spatial, looking at the topologies, the pictures, and try to remember those pictures very well and try to learn from these pictures faster than others. Some may have numerical abilities. So he identified these four abilities, which are S factors: mechanical, spatial, numerical, and verbal. So these four abilities, and then he said that in individual intelligence is a combination of these two factors. One is general and one is specific. So this technique that he used was to called the factor analysis, and concluded what he concluded. The test that I just proposed to you, Spearman concluded that the scores on these tests were remarkably similar. So why they are similar? Because there is a big G factor. So G factor is there for everyone, and then there is a specific factor, and then it will be difficult to deconvolute each factor G from S, but on a conceptual basis, intelligent machines or intelligent mind will have a G level and S level. Now, if you take this idea to the machine intelligence, in machine intelligence also, maybe if you're looking at image recognition, some may be may be able to do a general recognition and may be able to identify where there is a human face. And some may be more highly specific and maybe trying to identify which place there is a specific face X. So many there. This can be, some machines may be good at recognizing mechanical, some models, some mathematical models or the intelligent models may be good at doing a time series data. Some may be good at doing an image data, etc. So it may not be exactly this G plus S or two-factor theory may not be exactly mapped to the machines, but these ideas and nonetheless would be prevalent in some form or the other in the in machines also, in artificial intelligence as well. So, but then people, of course, went further than this, and then they found that it is not just the two factors, but there are multiple factors. And then Thurston in 1955, in 1900, later early 20th century and onwards, he gave this theory of primary mental abilities. So two-factor first, G and S, but then it goes further and it says that, Thurston says that there are several primary abilities, and he identified 7 primary abilities, mental abilities. One is associative memory, then numerical ability, perceptual speed, reasoning, spatial visualization, verbal comprehension, and word fluency. When you design artificial machines, incorporate artificial intelligence into your machines, in robotics and all, you will be dealing with these kind of issues. So just a quick view about what do you think is associative memory. I just take your understanding of this, and we'll move to the next slide. So I stop again sharing screen, and I will ask you, what do you think are these skills? What is an associative memory, you think? The term is itself self-explanatory. I just want you to participate and comprehend. What do you think is associative memory? Give an example of successful associative memory or a failing associative memory.
So associative memory is the connections that we remember, like something that we have seen or done.
Yeah. So I just quickly, I'll say the level of memory are not identical. For example, I have to get up at 7 o'clock. And exactly 7 o'clock, I remember I have to get up now. This is one type of memory. Another is that I have not missed my friend for a long time, but the moment I look at his face, I can see who this person is. So this is, do you think both of them require same level of memory, or one of them is weaker than the other? One of them is easier than the other?
The second one is easier.
Second one is easier, yeah?
Yes, because we are just associating the face with someone. So
exactly. So
unless we see the face, we can't remind.
Exactly. So this second memory is easier because this is a recognition level memory. It is in our brain, we can think of it that in our brain, we have a database of faces. And when we have some face, we match with that. I mean, of course, it doesn't happen exactly in this way, but you can think of this in a simplistic manner, that you look at the face and you process it in your brain, in your memory, it will be matched, and then an answer will come. So this is much easier. Then the memory that at exactly this time that your mental clock also has to work, and it has to remind you of something doing this. And then there are of course different levels of memory. Some are easier than the other. So when we say associative memory, we should be able to associate one particular observation with another particular observation, or we should be able to connect, as you said, the different experiences that we have. So our ability to associate ourselves is also an indication of our intelligence. Now, here again, this debate comes between memory and intelligence. So whether we are able to recognize people's face, or we are able to associate things because of our memory or because of our intelligence.
So because of our intelligence.
Because of the intelligence. Why not memory?
So because memory is just a database, with to map it with, we need intelligence.
Yeah, exactly. So we are able to recognize it because we are able to build connections. So memory does not build connections. Memory is just a storage of information. This also happens in computers. You may have either RAM, or you may have a hard disk storage where you can think that there's some kind of memory there, but you require some kind of computing to get the right information and trying to connect the different parts of so this mapping is stored somewhere else. So that does not have to be exactly coming from intelligence. It may come from experience or learning, or because of exact information that you store there. That is another element of memory. So, but our ability to build those associations, build those connections based on our experiences is our intelligence. So associating our experiences, associating our memory elements, and ability to recall them when we need them is one of the mental abilities, which is component of this theory of intelligence, which is associative memory. Second is numerical ability. So is easy to understand. So any of you who have appeared at these tests like GRE and GMAT, etc., you may be aware that they ask you for 2 or 3 type of question papers. One of them is numerical quantitative ability. So do you think a person who is intelligent will also be always intelligent in numerical abilities, or you can find people who are completely dumb in numerical abilities but they are much smarter and very intelligent in other tasks? Have you come across such people who are very good in numerical abilities but very bad in others? Or have you come across people who are not very good in numerical abilities but good in others? Can you think of any of your friends or any of your contacts who can be categorized in this? Or do you think if I'm good in, if I can speak well, I should also be able to have good numerical skills? What do you think?
No, sir, it is not necessary. Like, I think there can be people who are intelligent but not good at quantitative skills.
Yeah. So this is right. So there are many times that people are good in numerical skills, but they're not good in verbal skills. In fact, many people think that numerical skills are totally independent of the verbal skills. And we come across many people who speak very well, who write very well, and who can make very intelligent sentences, which requires a lot of mental ability. But they are very poor in numerical abilities. They can't remember their phone numbers. They can't do simple maths. Of course, part of this maths is because of your experience, because of your learning, but even inherently their numerical skill, numerical abilities may not be as good. So out of these 7 abilities, so this is the second one, numerical, and the third is perceptual speed. The ability, the slide says, the ability to see differences and similarities among objects. So you see objects, you can immediately tell, okay, this is triangular and this is spherical. Even if the triangle is little distorted, even the sphere is slightly distorted, you immediately generalize and you say that this object is different from this. So the speed at which you perceive things, and based on that you react, on a related point would be how fast we react to a particular situation. It is not intelligence, but then there is a perceptual speed and there is something called reaction time. How fast you react when you are driving and you suddenly see something in front. What is a typical reaction time? So in some places they will test you for reaction time and they will not give you a driving license if your reaction time is too slow. How long it takes if you're driving, you think, what would be a typical reaction time for a driver? Is it instant? When a driver sees something in front of his car, can he immediately react? Or there will be some time? When you see something, can you instantly react to your circumstance? Is somebody attacking you, can you instantly react or it takes some time? Or when something falls from your hand, immediately you are using something in your one hand and suddenly it drops and you suddenly bring the other hand to hold it. So this is your reaction, right? You know, your brain can quickly process that something has dropped and it immediately instructs the other hand to come and hold it. So this is our intelligence. Our mind works very fast. So it is our reaction time that is contributing to these tasks, the performance of these tasks. Everybody doesn't have the same reaction time. Some take longer, but it is much less than a second, right? So it has to be quick. So this can be measured. There are experiments, psychological tests to measure the reaction time, and people have done this. So but even before reaction time, the ability to perceive what we are seeing, observing, whether we can find differences. So sometimes, people complain that they do not notice if you change your hairstyle and you go to your class or you go to your family. Some of your family members will not notice that your hairstyle has changed, and some of them will immediately notice, okay, your hairstyle has changed. Your hair is 2 inches shorter than yesterday. So this ability to perceive the world around us and our ability to distinguish between our current observations and distinguish between our past observations and current observations is also a form of intelligence. And this is the intelligence that our machines would like to have. Our machines, our robots should be able to immediately tell that this is the person who is coming here. Suppose a robot is doing a security task. This robot should be able to distinguish that there is something amiss in this person. Although his eyes are still similar, but maybe his movements are different and maybe something is wrong. So this kind of differences, the ability to perceive the differences around us have implications, huge implications for artificial intelligence also. And that's why this discussion is important. And then the fourth one is reasoning. What is reasoning, by the way? In the last class, somebody said that intelligence should involve reasoning. And if I can expand this argument, what is reasoning, by the way? Can somebody elaborate what is reasoning?
Causal inference, sir.
Causal?
Getting, yes, sir. Causality.
Reasoning is causal inference? Something more than that? You're using another term, so I'll ask you, what is a causal inference? How can you make a causal inference?
So, if you take a decision, you are then putting the weights out, like what led to that decision. Like if you are choosing one thing over another, you have to give the reasons to convince
Can you make a
yourself.
causal inference from a single observation?
No, sir.
Can you reason out on a single observation?
Like, sir, like single
No, just
observation.
I'm asking. You observed something? Can you reason out something on this?
Yes, sir.
So this kind of distinguishes for you reasoning. I mean, of course, reasoning will be involved in all kind of inferences, but let me generalize this. So when we say reasoning, reasoning is basically formation of certain rules. Our ability to generalize, and then based on those general rules, we say whether this is valid or not. Our ability, if A is leading to B and B is leading to C, that is what you are saying, causal inference or causal sequence of events, then we should be able to reason out. And if this has happened, there must be something. If we see smoke, and we should be able to reason out, okay, this smoke is coming from some fire, so I will look for, I'll go further and look for where the fire is coming from. If I can smell something of a burning wire, I immediately notice that something is burning. So this is my ability to perceive. And then once I perceive that there is something wrong, I can hear some burning smell. I can notice that there is something burning. This first step of intelligence, where I could perceive something is wrong. Now, second step of intelligence, to be able to find out what is the reason for this, why this is coming, what is the possible reason that this could have been happening. So if I can detect exactly what is the reason, then I will go and try to find the solution and try to exactly locate what has gone wrong and which wires are actually heating up, and I will be able to fix that. So that would require a reasoning, and that would require an action which is guided by our previous knowledge and our understanding of the environment around us. Then remaining three are spatial visualization, the ability to visualize relationships between objects in space. Our verbal comprehension is the next one, and the last is the word fluency. So these are the seven mental abilities that this theory of intelligence has talked about. So I think we have spent about 40 minutes. I would like to give you a screen break because I am now coming to the conclusion that people should not be exposed to very long classes. So I'll give you 5 minutes break, and I'll rejoin in 5 minutes time. Just take a break, refresh yourself. And if you would like to discuss these topics amongst yourself, I'm not closing it off. I'm just turning off my camera, giving you 5 minutes, and reassemble in 5 minutes.